Welcome back, guys. In this video, we'll be discussing ICMP protocol. So, yeah, let's start. So, firstly, let's discuss what's the ICMP protocol is. So, generally, it's an protocol of Internet Control Message Protocol, and it's a network layer protocol that is used for the error messages, network diagnostics, and to convey the information of the condition about the network, and it plays a crucial role in the functioning of the internet. Okay, so let's just start with the lab of it. Yeah. In this lab, we'll be exploring several aspects of the ICMP protocol, like ICMP messages generated by the ping program, ICMP messages generated by the traceroute program, and the format and the contents of these both messages. So yeah, firstly, ICMP and the ping program. So over here, if we take a close-up look over here, it just says that let's begin this adventure by opening Windows command prompt and start up the Wireshark packet sniffer and begin the Wireshark packet capture. And the ping command is c/windows/system32. So either type ping and so this complete thing is a thing only for the Windows. So this command, especially this command which you are entering over here, ping slash n space 10 and www.usd.hk, right? So that command is only for the Windows, and for the Mac, if you want to uh, do it, you just have to use this command instead of that. Okay, for example, over here now I have done this, and yeah, I'll just paste this command over here and open the Wireshark in parallel, and I'm running it in Wi-Fi. Yeah, and now enter that ping command. See, there are some requests that are been happening, right? So what generally does this ping command is that it sends the 10 ICMP echo requests to a specified host called www.usd.hongkong, and it also displays the round trip time for each message. See over here in parallel, you can see that hold on a second. Yeah, in that command we can see that the 10 query packets and the 10 query response to each are received, and over here you can even see the average round trip time, like the average round trip time for this command in my computer has been 145.789 ms. Okay, so as everything has been captured, now just pause it up, and now your Wireshark and now open the Wireshark, and this is an ICMP, right? So just filter it with ICMP, and these are the packets that are captured over here. See, there are only 10 protocols. See, for example, over here, this is for the first ping request, and this is for the second, this is for the third, for fourth, for fifth, for sixth, for seventh, for so on, and for so on. It's like that. So overall, there are only 10 query packets that are sent and 10 queries that are received. Okay, so now let's just answer the questions for this. So firstly, yeah, the first question. First question is what's the IP address of your host and what is the IP address of your destination host? See over here, the IP address of my host is 172.16.56.145 and the destination is 143.89.12.134. Okay, and why is it that IMCP packet does not have any source and destination port? So actually, for that, see, actually the IMCP packet doesn't have any source and destination port numbers because it was designed to communicate network layer information between the host and routers and not between the application layer process. Okay, so for that, each IMCP packets, so each ICMP packets has a see, for example, for this, it has only a type and code over here. See, over here it has only type and code. So the type code combination identifies that the specific message which has been received since the network software itself, and it interprets the ICMP messages. So this is the reason no port numbers are needed to direct the ICMP message to an application layer process. Okay, next question. Examine one of the ping request packets sent by your host and what are the ICMP type and code numbers and what other fields does the ICMP packet have and how many bytes are the checksum sequence number and identifier fields. So for this, select any ping request. So I have selected the 62 segment one. So over here, so for this, the ICMP type is 8. Okay, and the code number is 0 and ICMP package has a see for the like what we have to do, uh, examine yeah, how many bytes are the checksum sequence number and identifier fields, right? See over here, for the checksum there are 2 bytes over here. Okay, for the identifier there are 2 bytes. Okay, and for the sequence number there are 2 bytes. Okay, so and there are other fields like type, code, checksum, identifier, sequence number, timestamp data. Okay, source and the destination. Next question. Examine the corresponding ping reply packet and what are the ICMP type and code numbers and what other fields does the ICMP packet have and how many bytes are the checksum. Okay, similarly for the what we have done for the previous request process, let's have to do it for the reply one. See over here, the source path is 143.89.12.134 and the destination is 172.16.56.145. Over here the type is 0 and the code is also 0. Code number is also 0. And similarly for this, just like the previous one, everything has 2 bytes only. Okay, so and both of them are almost same. Okay, the just difference is the type. Okay, in the previous one there is a type number 8 and here it's 0. Now we'll just move into the ICMP and the trace route command. Okay, so similarly, actually there have been given many things like ping plotter and trace route many commands. So in our computers like in Macs there is no need of any ping plotter. Okay, So we'll just see for similarly for this thing also over here in the Windows command, it is said that trace RT and the host name, right? So in the Macs, we'll just write the command as traceroot slash any domain name. Okay, if you do this completely, so when I have done it, there is no particular things like see over here. As I have tried previously, I was not able to get the traceroute command, guys. I don't know whether it's my laptop problem or anything. So I wasn't able to get it. So let's just wait and hope that I do get the traceroute command. So as of now, 11, we have got the 11 traceroute packets. Yeah, and we'll wait it, guys. Yeah, if for example, if you do not get the traceroute command, what we can do is that instead of this, go to ICMP Ithral Trace 2. See if okay, let's just close it up, and I don't think so we are getting it. Yeah, and what we can do for this ICMP trace route is that there are already the packets which have been done, so I'll just move to the ICMP Ithral Trace 2 in the Wireshark Traces packet, and we have got these specific things, right? So now just again unfilter it. So these are the packets that have been captured over here, and again let's start answering the questions. So yeah, and over here, what's the IP address of your host and what's the IP address of the targeted host? Okay, over here the IP address of my host is 192.168.1.101, and as a destination it's 138.96.146.2. Okay, so next question. If ICMP send the UDP packets instead, would the protocol number still be 01 for the pro packets? If not, what would it be? Okay. See, for that, open the Wireshark as of now. See, just select any ICMP, and over here, the protocol is ICMP, right? So, if ICMP have sent the UDP packets instead, the protocol would have been different, right? And the default protocol number for the UDP is 0x11. Okay, so next question. Examine the ICMP echo packet in your screenshot. If this is done different from the ICMP ping packets in the first half of this lab, if yes, okay. So yeah, open the Wireshark, guys. So yeah, now in this, what we have to do is that check whether if there is an error in the packet. Okay, the ICMP pass, so there is no particular error, and the ICMP error packet is not same as a ping query packets. Okay, so it was not same as the previous one which we have captured, and it contains both header and first 8 bytes of the original ICMP packet has the same error for it. Okay. So next question. Examine the last 3 ICMP packets. Yeah, 8 question. What examine the ICMP error packet? I guess so. We have done it. So yeah. We haven't done the 7th question. Examine the ICMP echo packet in your screenshot. Yeah, and what's the difference of it? Okay. Just now we have discussed this question and we haven't discussed this question. So for that, uh, see, actually there are no anything like as I have said, there are no particular error and there is no proper difference for this and for the previous first half what we have did. So that's it. And ninth question. Examine the last 3 ICMP packets that are wait a minute, yeah, that are received by the source code, and how are these packets different from the ICMP packets in the error messages. See the last 3 ICMP packets. Okay, over here, when we have selected the last 3 ICMP messages, 100, 101 and 102. See they all are a type of 0. Okay, and they all are echo replies. Okay, see if you see over here, let's say echo reply. See, right, for this you select this 98, 100 and 102. See, all three have the type of 0 rather than 11, which was the TTL, and they are different because all the datagrams have made the way to destination host before the TTL has exceeded, right? So that's the difference for the other packets and to these 3 packets. Okay, and last question. Within the trace route measurements, is there a link whose delay is significantly longer than the others, and on what basis of the route names can you guess location? Okay, so actually there is a link between the 1 and 1 2 steps, and yeah, this has been running continuously. So for this thing over here, there is a link between 11 and the 12th step that has a longer delay, and over here there has been a translatic link from US from the like going from one location to another location, right? So this is the reason there has been a longer delay. Okay, and thank you guys.